An isotope is an atom with the same number of protons and electrons but different number of neutrons. For example, a carbon atom would normally have 6 protons and 6 neutrons. However, an isotope would have 6 protons and 7 neutrons. Radioactive isotopes have industrial uses, such as detecting leaks in pipes and determining thickness of paper and metals. Radioactive isotopes also have medical uses, such as radioactive therapy to remove tumors, angioplasty, and medical imaging. This diagram shows one of the ways radioactive isotopes are used in medicine. Subatomic particles consist of protons, which have a positive charge of 1 and a relative mass of 1. Electrons, which have a charge of -1 and a relative mass of 1 over 1840. And neutrons, which have a charge of 0 and a relative mass of 1. Ionic bonding is the complete transfer of valence electrons between atoms. It is a type of chemical bond that generates two oppositely charged ions. In ionic bonds, the metal loses electrons to become a positively charged cation, whereas the nonmetal accepts those electrons to become a negatively charged anion. Metallic bonding is the force of attraction between valence electrons and the metal ions. It is the sharing of many detached electrons between many positive ions, where the electrons act as a glue, giving the substance a definite structure. A covalent bond, also called a molecular bond, is a chemical bond that involves the sharing of electron pairs between atoms. These electron pairs are known as shared pairs or bonding pairs, and the stable balance of attractive and repulsive forces between atoms when they share electrons is known as covalent bonding. A diatomic molecule is a molecule consisting of two atoms such as chlorine, fluorine, bromine, and iodine in group 7. Or it could also be hydrogen, nitrogen, and oxygen. Covalent bonds have low boiling points because between the atoms they are strong bonds, but between each molecule there are weak bonds. Covalent bonding could also happen in the macromolecular structure of carbon, such as graphite, which has a hexagonal layered structure. Diamond is also another example of a macromolecular structure. A diamond has a giant tetrahedral structure that allows it to have a very high melting and boiling point, and it also does not conduct electricity. Silicon 4 oxide is also another example of a macromolecular structure that has a giant tetrahedral structure. Besides the macromolecular structure, covalent bonding can also be simple. These are some examples of simple covalent bonds.